We introduced ETran, an energy-based transferability estimation. This work was done by Huawei Technologies Canada, and the paper was accepted at ICCV 23. There are a lot of pre-trained models available on platforms such as Hugging Face and other platforms, and the question that people may encounter and researchers may face is that how they can find the best pre-trained model for the downstream task. Based on that, the problem of transferability estimation is defined, which is given a pre-trained model, how we can find the best pre-trained model for a target task. The brute force solution for this problem is that we simply fine-tune each of the pre-trained model on the target task. However, this solution is time-consuming and resource-intensive. Based on that, transferability metrics have been proposed to efficiently find and rank these pre-trained models based on their performance on the target task. Prior works, usually most of them, they extract features by pre-trained model, and they use these extracted features and the labels that we have from the target dataset to kind of mimic the procedure of fine-tuning without actually fine-tuning and find the rankings of these pre-trained models. We argue that this procedure has a limitation, and the major limitation is that the features extracted by the pre-trained models drastically change after fine-tuning the pre-trained model. So basically, the features extracted are not reliable, specifically if the pre-trained model, if the target dataset is out of distribution for a pre-trained model. And the second limitation is that most of the prior works are mainly applicable to classification tasks, and they are not applicable to regression or specifically object detection, which is a combination of regression and classification. Our idea is that determining whether the target dataset is in distribution or out of distribution is an essential assessment factor. And our hypothesis is that the best pre-trained model is the one that the target dataset is less OOD for it. So based on that, we propose to use energy functions, which has been shown to be very effective in detecting OOD samples as an transferability estimation metric. So given the energy function, we find the energy values of target dataset on each of the pre-trained model, and we look at the energy values and try to find the best pre-trained model based on how OOD the target dataset is for the pre-trained model. The contribution is that the proposed energy metric is label and optimization free, which is very fast and effective, and ETran is applicable to classification, regression, and object detection tasks. Along with energy score, which is label and optimization free, we also proposed a classification score and a regression score in our paper. The classification score is based on linear discriminant analysis, which tries to distinguish and make the features distinct and tries to make the features more reliable. And the regression score is based on SVD. Our method is a combination of all these three scores. The energy score can be used alone as a metric. However, the combination of them, we have shown that it is more effective. So we feed the target dataset to the source models, extract the features, and feed the extracted features to each of these three scores, and the combination of them is used to find the final ranking. We performed extensive experiments on 4 benchmarks, a classification benchmark and 3 object detection, and our method altered from prior works. The analysis of energy scores shows that the energy values of pre-trained models are correlated with the final accuracy of the pre-trained model after fine-tuning. In terms of time complexity, the energy score alone is the best and the fastest approach. And however, the hybrid method proposed here by in our paper is also fast and it is the second best in terms of time complexity. Our application shows that all of these three scores are contributing to the final results on our 4 benchmarks. Thank you for your attention.